Alright, that's working. Sweet. Cool, so I'm going to just have a quick chat with you guys about the Lockwood V7. This is specifically about low security answers to high security locks. Some of you may have been at B-sides and seen the same talk, but it's sort of aimed, if you're a beginner picker, you might get something out of this. If you're an advanced picker, hopefully there's still little bits of information in there. So we might just jump right in, and there is a free V7 to give away to someone at the end of this talk, so stay for that and get yourself a free V7 lock. So we're going to quickly go over who I am, very briefly show everyone that GIF of how lockpicking works, because what's a lockpicking talk without the GIF? We're going to go over what a V7 is, how I opened a V7, or how Kleppers opened a V7 and then I cheated and used Kleppers' way of opening the V7, creating keys, and then a brief overview of what I learned. So I am a security analyst at TSS from Canberra. I've been lockpicking for 4 to 5 years now. Been messing around with a V7 for like 3 of those years. It's one of my favourite locks. It's also one of the favourite locks of a lot of people in the lockpicking community. It's just a lot of fun. It's a high security lock without the ridiculousness of like some of the Assa Abloy locks. So it's a nice little introduction going from a normal like pin tumbler lock into something a little bit more difficult. Lockpicking, how does it work? Just because nobody here knows that. This is how lockpicking works. It's pretty crazy. Just in case people don't know what I'm talking about, we're going to quickly go over like the key bits that I'm going to talk about. So we have the driver pins, we have the key pins. That's pointing towards the shear line. That's the wrong key. We've got like the lock core, the housing, and then the keyway itself, and obviously the warding being those little bits that are poking out. I'm sure all of you know what that is, but just in case. Yep, sweet. All right, let's talk about what a high security lock is, why we use high security locks. So a high security lock is just a lock that is designed to be highly resistant to compromise. Resistant being the key word there, because the goal isn't, well, I mean the goal might be, but realistically you're not making a lock that is impossible to beat. You're making a lock that is either too time consuming or too expensive for an attacker to beat. I don't know of any locks that can't be drilled with a very expensive drill and drill bit. So like you can definitely get through almost every lock. It's just, is it worth buying $10,000 worth of equipment, or am I better off going for a different target? I don't have $10,000 to buy a drill. So I used like $12 worth of equipment to beat this lock, which is designed to be unpickable, designed to be uncopyable, all that good high security stuff. There are a couple of defensive considerations that are worth running over when we talk about high security locks. If you're buying a $10 lock, the benefit you get from changing from a $10 lock to a $100 lock is, let's say, 10 times. The difference between a $100 lock and a $1,000 lock is not necessarily going to be 10 times. So there is a bit of a money sink as far as like, you are better off buying a more expensive lock up until a certain point, and then you start seeing less return for what you invest. It's also that locks are purely preventative. There are going to be other ways in. The aim of a high security lock is to mean that the lock is not the bit that you can compromise the most easily. What is a V7? For those that aren't familiar with it, a V7 was supposed to provide a cheap high security lock. There are 3 main security features. That is copy resistance. So the idea is that you can't copy the key without access to specialized equipment, and it's obviously restricted keyway, restricted blank. Access to the key is also one of the controls that Lockwood sort of talks about when they talk about the V7 system. It has restrictive keyways, the idea there being to hinder any attempts to pick it, and it has manipulation resistance, so security pins, anti-drill bearings, all that fun stuff. The manufacturing tolerances on these locks are surprisingly good. They're actually not very easy to pick. They take a lot of work, but possibly a little bit easier than you think. So this is what a V7 looks like. You can see on the left side, this is like a cross-section of the V7 from the original patent, and you can see the pretty significant V shape in the way that the pins are set into the lock. Pointing there specifically. So that means that the key is cut on angles, so that the pins sit rested on it. So that's what makes it difficult to cut, basically. Image 2 is a photo of the one on the right. Yeah, that's a photo of the lock core itself. And you can see pretty clearly there that the pins are offset from each other, not in a straight line like you would usually see in a lock. And so that's what allows the pins to be drilled in on an angle. That bit there is where the anti-drill bearings go. It's just meant to make it harder for you to drill it, basically. All right, so how do we open a V7 without using a key? There are a couple of difficulties. Number one being the keyway design. It has a couple of different keyways. All of them feature some pretty significant warding. It's not anything ridiculous, but it's enough to make it a bit difficult to jam your pick in there and fiddle it across the different angles that you need to get to in order to hit that V shape. Obviously, the pins in a V shape means that you have to switch from one side to the next if you're just going front to back. That's pretty much the main control that Lockwood implemented was, let's make it kind of difficult for people to get in there, we'll make it a V, but then they didn't put heaps of thought past that into making it difficult to pick. They usually have at least 1 or 2 security pins in them if you get them straight from the factory. They're not like anything crazy. It's just like a normal mushroom pin and all the ones that I have. So I've got like 5 of them, and all of them had 1 security pin except for one, which didn't have any. So the first time I tried to open a V7, I spent 6 months fiddling with it, couldn't do it, gave it to Kleppers, and then Kleppers gave it back to me picked and gutted. And I was like, how did you do that? And he was like, I couldn't do it either, so I just shimmed the lock. So he just stuck a piece of metal in between the core and the housing, and then picked it pin by pin. And I was like, that's not good enough for me. I want to learn how to actually pick these. And so I just started building it back from, 1 pin in there, can I pick that? Yes. 2 pins in there, can I pick that? Yes. Went back. And it turns out that the issue was that I thought that it was difficult to pick. And the answer is, it's like a normal lock with 1 security pin in it. And you just have to not do anything silly like saying, like, do I have to pick the left side first then the right side? Or do I have to alternate? Like, it's the same as anything. You feel for the one that's binding, you click it up, like it's not that difficult. Like the manufacturing tolerances are pretty good, so maybe you don't get as much feedback as you would hope, but there's nothing that special to it. Shimming is probably the easiest way though. What I mean by shimming, if you're not familiar with it, is just putting a little bit of, that's not what I want, that is. You can put a little bit of metal in there, aluminium can I guess works, because there's a bit of space there. And then you can just sort of put your pick in, push each pin up one by one as you push that metal towards the back. And so when a pin binds, it just sits either side of that metal and you don't have to worry about like keeping it tensioned or anything like that. So that's not so much fun. So I was like, all right, so now I can pick this lock. So we've beaten the unpickable aspect of it, but the more fun bit is creating keys for these. The way that I did it was I did it on a lock that had already been picked and already been stripped. I think it's possible to do this, like if you were to say like in the field by using impressioning, but I haven't tried it, or I haven't tried it enough to get it to work. So theoretically I think it is possible, but it's quite difficult. So the way that I did it was I took the lock, I took it apart, and I went pin stack to pin stack. And I'm sure a lot of you guys have done this before, but if you haven't, this might be something interesting. So there are a couple of challenges, a couple of things I wanted to do. So I wanted to open the lock, number 1. The next thing I wanted to do was to create a working key that I could easily duplicate, or that really anyone could easily duplicate. So step 1, I need to identify a blank that would work in this lock. Step 2 was I wanted to hand cut all the pins. And then step 3 was I wanted it to be copyable with a machine. So we faced a couple of different challenges. Number 1 being that there's like 8 different keyways. And I wanted to have 1 or 2 keys that would fit each of these keyways. Number 2, the relatively significant warding means that you actually have to be a little bit careful about what keys you pick, because I wanted to be able to say, all right, I've got 2 different keys or 2 different blanks, and these will fit all of the V7 keyways. And then number 3 is you've got that little V at the top of the keyway. I'll see if I can go back there where that red arrow is pointing. It's not super clear, but there's a little V poking out of the top of the keyway there, because the lock has like the key has like a V cut into the center of it, straight down the middle, so that the key can slide in. So obviously, any key that you're putting in there, you either need to have that V or you need to find a way around that. You can see it on the key here quite clearly that there's that little like ridge cut into the center. You can also see in the second image that despite the fact that the lock is kind of, or say the key is kind of funky looking, it's got angled cuts and all that, there's still just 7 cuts in that key. So I thought, since there's still 7 cuts, it's not like there's 2 at any one point, we can just do this like a normal lock. We can just cut the pins straight and just go from there and see how we go. So identifying a blank. So what I did was, I believe it was Rainer sent me the original patent for the Lockwood V7, and in that you've got all the different keyways. And so I went through those, and those ones, which all look pretty similar, and I just jumped into Photoshop and I overlaid them on each other. And you can see that there's sort of one pretty distinct shape. From this distinct shape, I mean, I was pretty lucky, but if you look at it and you go, what does that look like? Kind of looks like that, which is an LW5, like the single most common key ever created, fits into a V7, the restricted keyway that is supposed to be uncopyable, the keys are unobtainable. So, not great thinking. The only thing that you will notice that when I overlay them, you can see that the key is poking out the bottom, and the key also doesn't reach the top. So we've got a key that'll fit in, or it'll get into the lock, but it'll poke out the bottom, so we need to fix that. And you also won't be able to get any high set pins, basically. There and there. So that's a TE2, because it turns out that there are basically like 2 different families of V7s, and the LW5 fits in one and the TE2 fits in the other one. So that's a TE2. The reason that I use this is because you can see it poking out of the bottom a lot more. So you've got this, like the lock core, it fits in there, it's all good, but you've got it poking out the bottom, so it won't actually get into a lock that's in use. So the solution to that is simply to take sandpaper or a file to it and file it down into shape. And then all you're missing is there's a small gap in the top where that V is, where your key doesn't reach the top. But that's problem 1 solved. So the next step that I did was I ignored the top bit and I went on to cutting the pins by hand. So as with any sort of manual cutting, I just went through, put the key into the lock, got a marker, went through each of the pinholes and marked on the lock where I wanted to cut. And then, as per usual, you just sort of put the key in, put a pin in top, see if it's poking above the shear line. If it is, file it down a bit, try again, and just do that over and over. I just used like $6 jeweler files that I bought online. The blanks were like 50 cents. So this is Lockwood's super secure V-shape craziness, beaten with like $8 worth of tools. So I filed down each one, reinserted it till it was at the shear line, and did that over and over. I just ignored anything that was below the shear line because I can't unfile this key. If you overfile the pins as well, it's not such an issue because we're going to fix that later. So this is the process that I went through. You can see the pin poking out above the shear line there. That's with an uncut key inserted. Then I filed down that specific spot, and you end up with a really ugly file. But if you have a look at the other green arrow on the top right, you can see that pin's now sitting flush with that shear line. So if I do that to all of the pins, that lock will now rotate, except for the driver pins that are on the ones that are below the shear line. So on that last one, you can see all those pins have been filed down, but there's a couple of them, the second last one, for example, which is actually sitting below the shear line, which means that if you just stick that key into the lock, it's still not going to rotate. Although you're like, in this case, I was 5 pins were correct, and then there was 2 that I needed to fix, basically. So next thing I wanted to do was I wanted to copy the key by a machine, still ignoring those high-cut pins. So there are a couple of major benefits to cutting with a machine. Number 1, it's smoother. So this little U shape, when I cut it with a machine, or rather when I took it to Bunnings and asked them to cut it with a machine, turned from a really sharp U into a pretty nice sort of flat shape that isn't going to get jammed when you put it in the lock. Simply because, I don't know if you can see it super clearly, but this bit here sort of overhangs a little bit as far as like you've cut underneath and come back because it's a circular, well, I was using a circular file. which means that the key machines that they use at Bunnings or any other tracer machine isn't going to be able to, it's going to go forwards, it's going to hit that come back, but not cut anything. So you'll just end up with like a little bit flatter. So it ended up more or less cutting up to about here and then going on to the next pin because like the machine's just not equipped to cut it with that much accuracy. The other thing is it's reproducible. So I now have a key that was cut by Bunnings that I can take back to Bunnings and get 50 copies made. Or if you find a copying machine on eBay for $50, you can make like 600 copies. The time per key is a lot less. Cutting pins by hand sucks. Like it takes so long. You get to like the last pin, you accidentally file one too many times, you've screwed it up, you go into a new blank, you break that one. It's not fun. This is like, drive to Bunnings, hand them your stuff, go buy some topsoil, come back and your keys are done. You've got 50 keys that you can now use. So it's a lot nicer, and you've also got a nice base image now. So it's something that you can use to, like you can build off of that and mess around and see if you can get it working well. So Bunnings worked really nicely. That's the Bunnings key. So you can see that first cut compared to that one is a lot smoother. And actually it doesn't get jammed in the lock. It's not the prettiest key ever, but it's mine. So it looks nice. You'll also notice that the last couple of pins are still sitting at the normal blank level. That's because those ones were sitting below the shear line. But we're going to fix that now. And we're going to get those sitting where we want them to. So the answer is solder. That's it. I spent a long time thinking about how I could do this. And then I think someone was just like, why don't you just solder it? And I was like, that's ridiculously easy, and it works. So you can't file a key up, but if you put solder on top of it, you can file the solder down. It sticks surprisingly well to the keys, which is like not expected. I was like, this is going to jump straight off as soon as I put it into a lock, but it doesn't. So what I did was, initially I put the solder onto the key. I filed it really carefully to get it into the right width. And then I filed it down so it would just sort of fit into the lock. And then I got the end of my jeweler's file and I very carefully filed a V into the solder so it would fit into the lock nicely. That sucks. So what we do instead is you get your solder on it into a sort of vaguely rectangular shape and you just kind of jam it into a lock core over and over, and you just let the lock cut the solder for you, because like the lock's not made out of solder, it's a lot harder. So that little V in the top of the lock core will cut straight through the solder, and then the size of it will also file it down. So all you have to do is file it down to the point where you can fit it in, and then just smack it a couple times, and you've got yourself a lovely, perfectly shaped end of the key. And then from there, same thing as before, you just stick your pins on top, file down in each spot where you want the pins to sit, and what you end up with is this exceptionally ugly blob of solder on the end that fits perfectly into your lock and opens the key, opens the lock exactly how you want it to. So it's not pretty. Maybe it's not that like scientific, or the techniques might not be all that great, but it does show using just like some really cheap materials how you can sort of create a key where they don't want you to. So the main points from this, or the main things that I took away from this, was that high security locks are designed to take more time than a normal lock, but they're not unbeatable. The V7 is a really fun introduction into the whole mentality behind beating high security locks, or at least at a base level, thinking a little bit further than just picking them and creating keys the normal impressioning way. And then I have no idea what my offensive considerations were. I guess offensive considerations would be that, number one, V7s are openable without a key. They're also copyable without a key. Well, sort of copyable without a key. They're copyable without a key as long as you can pull the lock out, take it home overnight, and then come back the next day and no one's going to notice. So maybe not red teaming, but I guess if you're breaking into a bank that uses V7s, you might make it. I've actually got a V7 here to give away. Does anybody remember what the 3 main security features I mentioned at the start of this presentation were? Because that's what I was thinking people might remember to give this away. But if not, we might just get someone to rock, paper, scissors.
Key control, the V shape, and the export.
Yeah, cool. That'll do. There you go. This has got one key, a bunch of pins, a core, all that stuff. Have fun.
Sweet. Cheers.
All right. Does anybody have any questions? Yes.
Did you play around with getting the keys and using bumping or anything like that? Did that have any effect with the V-shaped or the pin alignment?
Sure. So just to repeat that for the audio recordings, the question was, did I mess around with bumping the lock? I haven't messed around with bumping the lock. I think that would still work. Actually, I take that back. I don't think that would work. Because if you cut down each of those pins to the lowest level, like a normal bump key, I suspect that the high set pins wouldn't reach the key. It's like in order for it to work, just because of that V shape, I think you'd have difficulty getting it to be such that each pin would actually get bumped. I mean, it'd be worth playing around with for sure, because if you could get that to work, I don't see any reason why bumping wouldn't work on these. There's nothing specifically built in to prevent that from happening. I think when these were made, bumping wasn't even really a thing. But that could be worth having a look at. So I might mess around with that, and then I guess I'll post in the Sec Talks or something and say whether or not we found, or the Lock Sport Slack, and see whether or not that works. Because that's an interesting idea. Yes?
Did you contemplate, seeing as you had like a perfect profile, just 3D printing them?
I actually did 3D print these. So the first thing that I tried was, I tried 3D printing just blanks that I could then copy. The issue with that was that with the plastic ones, they broke really quickly, and they also didn't file down very nicely. So I gave it a crack. That didn't work so well. I then tried casting from those, and that worked really nicely, but it was too expensive for me. So casting was costing me, like, I think it ended up being like $30 or $40 per key if I bought like a lot of keys, versus the Bunnings blanks, which was like $1.50 for a blank and 50 cents for, you know, a bit of solder on top or whatever. So it definitely works. They're quite good. If you use, you can get these like little handheld casting kits as well, and I've tried those on some of the V7s that I have keys for, and they work quite nicely. But the issue is, like, it's quite expensive, more or less.
Is it plastic and retention tool, or you don't, if you're printing or 3D printing your blank, what you're using that retention, just slide in retention tool, so that way the plastic's only for the combination retention tools for the tool.
Yeah, that'd probably work. It's just, again, if you start using that key in the field or whatever, like eventually it's going to break or wear down. But that would definitely work for making keys for this. Yep. Yes.
Did Bunnings give any shits?
No, absolutely. They had no idea. I mean, like, they're not really trained to know or care. The key that I brought in was one that they have blanks of. The only thing that you'd really notice was that it was cut really jankily, and the last couple pins weren't filed, but like they're not paying that much attention. So, I mean,
Can you take off the little bottom bit?
no, that would have made my life a lot easier, but I didn't. Yeah, I just took it in. It was missing the bottom bit when I got it cut as well, but for some reason that didn't affect it. You would think it would, because it would sit a bit lower, but I guess if you're using the ridges in the middle of the key to sort of line up versus the bottom of it. But yeah, they didn't question at all. They were just like, yeah, how many do you want? I was like, 50? Sweet. Any other questions? Yes.
Not really a serious one. Did the $12 include the Bunnings sausage?
I bought more than one Bunnings sausage, so I think including snag and drink fees, we might be more up at like $15, $16. Depending how many trips you go to Bunnings, because can you even go to Bunnings without getting a snag? No. Yeah. All right, awesome. Thank you guys very much for listening to my talk.